You know, it just blows my mind that the oldest piece of woven fabric ever found, hemp.
Really? That old?
Yeah, and get this, the original Levi's jeans, like the very first ones, were apparently made from this super tough hemp canvas.
Wow.
There's even a pretty strong theory that the first American flag, the Stars and Stripes, might have been hemp too.
That's incredible. I didn't know that history.
Right. Okay, so let's unpack this, because this plant, industrial hemp, it's often kind of overlooked, but it has this amazing story woven right into, well, the fabric of history.
Definitely.
Today, we're doing a deep dive into its big comeback. It's reemerging as a really sustainable material, not just for clothes, but like all sorts of industrial uses.
It's fascinating, isn't it? Most people have maybe some idea about hemp. Perhaps they even confuse it with its more famous cousin.
Right. Exactly.
But our goal today is really to go beyond those basics. We're digging into some pretty recent in-depth research, particularly a study from 2025 in Textila Industria, to see what industrial hemp can really do.
Yes, because for a long time, hemp got pushed aside. There were regulations, about the THC content, even though it's minimal in industrial hemp. And then competition from big players like cotton really squeezed it out. But here's the really interesting part. It's making this powerful return.
Yeah.
And it's not just some trend. It seems driven by a real need for sustainable options and finding all these cool new ways to use it.
And our mission here is pretty straightforward. We want to give you the whole picture, from how it's grown, its cultivation,
right,
all the way through to its diverse applications. We'll look at the unique properties of its fibers, its growing role in textile, sure, but also construction, and even these advanced materials called biocomposites.
And crucially, how does it stack up environmentally compared to, say, cotton?
Exactly. That comparison is key.
Okay, so let's roll up our sleeves. Let's start right at the beginning, the farm. Hemp has this incredible history, but like we said, cotton's rise and those regulations.
The THC issue,
really took a toll. But it's so important to keep saying the industrial hemp we're talking about. Less than 0.3% THC, completely different plant in terms of effects.
That distinction is critical. And what's remarkable is, even with those historical hurdles, hemp itself has always been this incredibly versatile and economically sound crop.
How so?
Well, think about it. From one plant, you can get paper, oil, seeds, insulation, fiber, even construction materials.
Wow, okay.
And it grows relatively quickly, doesn't need a ton of inputs. That makes it pretty appealing for a lot of different industries, not just textiles.
So farmers grow it for different reasons?
Pretty much. Usually it's one of two main things. Either for the seeds, think oil dyes, fuel, food, medicine, cosmetics.
Okay.
Or for the strong fibers in the stock.
Yeah.
And those go into composites, insulation, paper, building stuff, clothes, rope, you name it.
It's amazing tracing its journey, like starting in Western Asia thousands of years ago.
Ancient history.
Then spreading through Egypt, Europe, becoming really important, and then it jumps the ocean to America in the 1500s. America actually became a major producer.
Right.
And it wasn't just like basic stuff. It was vital for ships, the ropes, the sails. Think about those early explorations, probably powered by hemp.
It's like this quiet backbone through history.
Totally.
And the reasons for its comeback now are really compelling. The research highlights just how cost-effective it is to grow.
Because it grows fast.
It shoots up quickly,
Yeah.
Relatively easy to harvest and process.
Yeah.
And it doesn't demand a lot less water, fewer nutrients, fertilizers, pesticides compared to many crops.
That's a huge plus.
And what's also great is its effect on the land. It naturally suppresses weeds, and it can actually regenerate the soil. So it's genuinely sustainable. These advantages are really driving the interest we're seeing now.
Okay, so if you're thinking about growing it, the first step seems crucial. What do you actually want to do with the hemp?
Exactly. It's an annual plant, tons of uses, but it all comes down to the specific variety you plant.
So picking the right seed.
Absolutely critical. The species, the seed's characteristics, that determines everything. How tall it gets, how thick.
Right.
When it sprouts, the oil content in the seeds, the fiber yield from the stalk, and even the best time to harvest it.
Okay, and what about where it grows? Is it fussy?
It has preferences. It really likes soil that's rich in nitrogen and minerals, and importantly, drains well.
Doesn't like wet feet, huh?
No, definitely not. Hates overly salty, acidic, or heavy clay soils. Water is key too. Needs about 650 to 750 millimeters over its life.
That sounds like a fair bit.
It does, but the peak need is really in those first 6 weeks when it's growing fastest.
Yeah.
And interestingly, if the drainage is good, it can often manage with pretty minimal intervention.
And climate.
Prefers it mild and humid. Ideal temperature is around 20 to 25 Celsius, though it can handle a bit cooler or warmer.
Really?
You plant it in the spring. It's not a fan of the cold.
Got it. And harvesting, you mentioned timing is key.
Oh, absolutely everything. For the best fiber quality, mid-August is often the sweet spot. That's usually when the plant has the highest fiber content and is just starting to release pollen. But again, this can shift depending on the specific type.
And they can get pretty tall, right?
Oh, yeah. Anywhere from knee-high to several meters tall. It really varies.
So what happens if you harvest too late?
Big problem. The hemp gets overripe. You actually lose some of the valuable cellulose, the stuff you want for strength.
Right.
And you get more lignin and pectin, which aren't ideal and can even damage the fibers.
And too early.
Also not great. The fibers just haven't fully developed their length, strength, or durability. They're more likely to break during processing. So timing is crucial. Stepping beyond just growing it, it's vital to appreciate just how many different things industrial hemp can be used for. Textiles are big, yes, but
there's more.
A lot more. Composites think strong, lightweight materials, insulation for buildings, fuel, rope, even medical and cosmetic uses, and surprisingly, plastics.
It really makes you wonder about all those restrictions it faced, doesn't it?
It does. Given how relatively easy it is to grow and how incredibly versatile it is, the research we're looking at strongly suggests, rethinking those limitations.
And encouraging a well-managed expansion.
Exactly. In a world that's increasingly focused on sustainability, cutting down a reliance on synthetic fibers is essential. Natural options like hemp, they offer a really promising path forward.
Okay, let's zoom in on textiles then. What makes hemp fiber special for clothes and fabrics?
Well, chemically, it's quite unique compared to, say, cotton or flax. It has higher levels of lignin and pectin.
And that matters because
those amounts really influence how the fiber behaves during processing and what its final properties are, like strength, for example.
Is it stronger than cotton?
Significantly, in certain ways. It has higher strain tension values. Basically, think of it as being incredibly resistant to tearing and stretching.
Oh, okay.
That makes it ideal for things that need to last and take some stress seats, carpets, ropes. Combine that with the fiber length, its shape and cross-section, how fine it is. Hemp really stands out.
You mentioned shape. What's that like?
It's fascinating. Under a microscope, the cross-section is kind of polygonal, and it's hollow inside.
Hollow, like a tube.
Sort of, yeah. And that hollow structure is amazing. It gives a great heat retention, sound dampening, and moisture absorption.
Which translates to comfort for us, right? Keeping warm, absorbing sound, handling moisture.
Exactly. It protects our skin, can even help prevent microorganism growth.
Oh, wow.
Plus, that hollow structure makes it lightweight and gives it a soft feel. And on top of that, it's naturally antimicrobial and breathable.
So perfect for clothes, t-shirts, baby clothes.
Socks, medical supplies, even shoes. The applications are really broad because of those properties.
How does it stack up directly against other natural fibers then, like in numbers?
The research has tables comparing them. If you look at cellulose content, that's key for strength. Hemp holds its own really well.
And yield. How much you get per acre.
That's another big plus. Hemp often outperforms cotton significantly in terms of annual fiber yield per hectare, and the fibers themselves are longer. That combination of strength and high yield is a major advantage.
Okay, so we know how amazing the fiber is, but getting it out of the ground?
Yeah.
How does that work? Is it all machines now?
Mostly, yes. Harvesting by hand is tough. The stalks are long, growing areas can be hot and humid, and labor costs keep rising. So mechanization is pretty much necessary.
Where do these machines come from?
A lot of the current tech is from America and Europe. But here's the thing. Their focus has often been on hemp for oil, paper, composites.
Not necessarily textiles.
Right. So the machines are often designed to cut the stems into shorter pieces. For the long textile fibers they need, they often end up importing them.
Ah, okay. Which is different from China.
Exactly. China uses a lot of hemp fiber for textiles, so they need those long fibers. The American and European machines aren't always ideal.
Why not just use them anyway?
Well, besides the fiber length issue, China's landscape, more mountains, smaller farms, makes those big, heavy machines less practical.
So they developed their own?
They have, yes. Smaller, more maneuverable machines.
Yeah.
But they've still faced some challenges, particularly with how the fiber gets collected and wound up efficiently after cutting.
Are there specific machines mentioned in the research?
Yeah, a few.
Hmm.
In the U.S., there's a planter called the Triumph Model 4 that plants, waters, and even starts softening the seedlings.
Cool.
In Europe, you see stock piece-by-piece harvesters, like the Hempcut 3000, 4500. but they cut shorter lengths, like 60, 70 centimeter, which isn't great for textiles.
Any that cut longer.
There's another European one, the Clipper 4.3 mmH, uses 3 blades and can cut to about a meter.
Okay.
Then you have double cutting harvesters, an improved Hemp Cut 4500, and the John Deere W660 that does hemp and flax. They cut the stem in 2 places, separating the top and bottom.
Why do that?
Makes it easier to collect the leaves and seeds later. There's also a drum-type harvester that processes vertically, which is a different approach mechanically.
And the Chinese machines.
Professor Li Xianwang's team developed wheeled and tracked ones, like the 4GM 1.85 and 4GM 2.2, designed for their specific needs. The research even compares specs, like working width, speed, power needs for some European models. Shows the different design philosophies.
Okay, harvest done, stems are cut, what's next? Seems like what happens after harvest is just as important.
Absolutely crucial. First step, get rid of the leaves and the flower heads.
Why is that so important?
It's essential for the next stages, the soaking, called retting or pooling, and then the drying. You need clean stems for that.
Okay, so drying first.
Usually, yeah. They spread the bundled stems out in the field. This helps reduce the pectin, that sort of natural glue in the plant. You want the moisture down to about 15%.
Then the soaking, the retting.
Right. Immerse the bundles in water ponds, streams, special pools for maybe 15 to 30 days.
That long?
It depends. Depends on how much lignin needs to break down, and also the water itself, the microorganisms in it, the temperature. Those microbes do the work.
So after drying and soaking, the sticky stuff and the woody stuff are mostly gone.
Largely broken down and washed away, yeah. Then the stems get bundled into bales, sent to processing plants.
And that's where they finally get the fiber out.
Exactly. Special machines separate the outer bark and the inner woody core from those long fibers. Then washing, cleaning, get rid of any leftover bits.
And finally?
Carding. It's like running the fibers through giant brushes to align them all nicely, ready to be spun into yarn.
Now, you mentioned cannabis cousins earlier. Can we just clarify the different types?
Good point. Cannabis sativa is what we're talking about, industrial hemp. Long fibers, very low THC, used for fiber, oil, seeds.
Okay.
Then there's cannabis indica, typically shorter, higher THC, grown more for medical uses.
Got it.
And cannabis ruderalis is smaller, often used in breeding to create hybrids. And classifying the fiber itself, hemp is a bast fiber.
Bast fiber.
Means it comes from the outer layer, the bast, of the plant stem. It's in the plant fiber category, along with seed fibers like cotton, leaf fibers like sisal, and fruit fibers like coir from coconuts.
Right. Let's circle back to why hemp is getting all this buzz now, its properties. Environmentally, it seems like a winner.
It's a real standout, yeah.
Yeah.
Especially if you think about potential future problems with petroleum-based materials for things like composites.
And compared to cotton.
Generally easier and more cost-effective to grow, as we discussed. Less water, fewer chemicals needed.
And physically, is it strong?
Remarkably strong. It's actually one of the strongest natural fibers out there. It can even compete with some synthetics in terms of tensile strength that's resisting being pulled apart.
Wow.
And it's also relatively light, low density. Huge plus for composites in cars or planes where weight matters.
What about chemically?
Pretty resistant to things like mold and pests. But it does like to absorb moisture from the air.
So sensitive to humidity?
Can be, yeah. That's something to consider in applications. High humidity absorption.
Let's dig into the nitty-gritty. Physical, structural, mechanical properties. What's it made of?
Main components are cellulose, hemicellulose, lignin, and pectin, plus small bits of waxes and ash.
And what do those do?
Cellulose, with its ordered structure, gives it that high strength. Hemicellulose adds some elasticity and helps it absorb moisture. Pectin is like the glue holding cells together, also helps with water retention.
And lignin?
Lignin provides stiffness and structure to the living plant. But in the fiber, it can make it harder, more brittle. So often, some needs to be removed during processing, especially for textiles.
Does the exact mix of these things change?
It does, yeah. That's important. The chemical makeup can vary quite a bit based on where it grew, rainfall, age at harvest, how the fibers were extracted.
So that variability could be a downside, like less consistency than synthetics.
That can be a challenge for large-scale manufacturing, definitely. Consistency is harder with natural materials.
But generally, it's considered very strong and stiff.
Oh, yes. One of the stiffest and strongest natural fibers. Its stiffness is actually pretty similar to glass fiber.
Wow.
And interestingly, its strength can even go up a bit when it gets wet. It's also resistant to extreme temperatures and doesn't pill easily. You know those little balls on sweaters?
I hate those.
Yeah. And its humidity absorption is significant, as the research details. Like 12% moisture content at 65% relative humidity, up to 30% at 95%.
Those comparison tables you mentioned earlier, how does hemp look next to jute or flax?
Really good. Its tensile strength, that resistance to breaking, is impressive. Puts it in a strong position among biomaterials.
Any areas where it's not top?
It tends to have a lower failure strain, meaning it doesn't stretch as much before breaking. And its specific stiffness divided by density, is lower than some. But because it's less dense, that low density is often an advantage for lightweight applications. If you could zoom right in, microscopically, what does the fiber structure look like? The research shows figures, right?
Yeah, it's layered. You've got the outer cuticle for protection, epidermis for gas exchange, cortex for storage and strength.
Like layers of an onion.
Sort of. Then the phloem and xylem, the plant's plumbing. Between the cortex and the center, you find bundles of tiny fibers held together by the middle lamella, which is mostly pectin.
And the fiber walls themselves?
They're key. The primary wall and the secondary wall layers give the fiber its strength and flexibility. One secondary layer, S2, is especially important, packed with cellulose, hemicellulose, lignin.
And didn't you say it was hollow?
Right. The lumen, that hollow center, helps the plant regulate pressure, store stuff, and it's a big reason the fiber is lightweight.
Fascinating structure. So for thousands of years, we use this for clothes, shoes.
Yep. Clothing, shoes, ropes, carpets, tarps, those ship sails and ropes again.
And the Levi's and the flag story.
Exactly. And now it's getting recognized again as this eco-friendly, high-yield, fast-growing alternative.
A sustainable alternative to cotton and synthetics.
Definitely. Because the traditional textile industry, it has a big environmental footprint, right?
Huge. And even cotton, though natural, needs enormous amounts of water and chemicals.
How does hemp compare on water?
Significantly better. The research cites figures around 2,100 liters of water per kilogram of hemp fiber.
Okay.
Compared to maybe 10,000 liters for the same amount of cotton.
10,000? Wow, that's a massive difference.
It really is. Plus, hemp fabrics tend to last longer, potentially up to 30 years, compared to maybe 10 for cotton. That durability adds to its sustainability.
And comfort-wise, we talked about the hollow structure.
Right. That gives it great properties. It absorbs heat, regulates temperature, keeps you cooler when it's hot, warmer when it's cold.
Nice.
Holds color well, naturally antimicrobial, hypoallergenic, even offers some UV resistance. And because it's strong, it resists stretching and wear.
Sounds good for household stuff, too. Towels, sheets.
Definitely. It's absorbent, durable, and can even help filter some toxic gases, apparently.
Beyond clothes and home goods, what about more technical uses? Insulation.
Yes. Building materials. The construction sector has huge greenhouse gas emissions. Hempcrete is emerging as a really interesting bio-based alternative.
Hempcrete, made from hemp.
Yeah, hemp hurd, the woody core, mixed with a line-based binder. It gives good thermal insulation, helps make buildings airtight, improves indoor air quality.
And
Get this, it actually absorbs CO2 from the atmosphere as it grows, and through a process called carbonation as it cures.
so it's carbon negative.
Potentially, yeah. It's a really exciting area.
What about paper? You mentioned that earlier.
Right. Hemp paper's been around for ages. It's stronger and more durable than wood pulp paper, especially when wet.
Doesn't yellow either.
Doesn't yellow over time.
Yeah.
Can be recycled more times than wood pulp, and often doesn't need bleaching.
Which is better for the environment.
Much better. Using the whole stem makes it sustainable. Demand for paper and cardboard is still high, so hemp is really well positioned there. There are already like 23 hemp paper mills worldwide.
And composites.
That's another big one. As we look for alternatives to fossil fuels, natural fibers like hemp are key for creating these advanced materials.
Because they're strong and light.
Exactly.
Yeah.
Major advantages. You can use hemp on its own or mix it with other fibers. And if you use plant-based resins, the whole composite can be more easily recycled.
What are composites, basically?
You have a matrix material, like a resin, that holds everything together. And reinforcement, like the hemp fibers, that provides the strength. The combination has different properties than the individual parts.
Where are we seeing hemp composites used?
All sorts of places. Construction insulation, wall panels, automotive lighter parts mean better fuel efficiency, furniture using recycled hemp scraps, packaging biodegradable foams, even sports gear.
Sports gear?
Yeah, racing vehicles. Did you know the first car body partly made from hemp was back in 1937?
No way.
And researchers are even looking at it for lightweight parts in aviation, like for X-ray devices or coatings.
So the advantages in composites are...
easier and cheaper to produce than many other fibers, less energy needed, recyclable, sustainable, low carbon emissions, durable due to the cellulose, lightweight.
Okay, sounds great. Any downsides?
Well, that tendency to absorb moisture, its hygroscopic nature, can be an issue. In very damp conditions, it could lead to rot or structural changes.
Right, humidity sensitivity.
And being a natural fiber, its structure isn't perfectly uniform like synthetics. That heterogeneity can be a challenge for consistent performance. Fiber quality depends a lot on growing conditions, harvesting.
Makes sense. So we've talked about all these uses and properties. How do we actually measure the total environmental impact? You mentioned LCA.
Right, life cycle assessment.
Yeah.
It's a standardized methodology defined by ISO standards, actually.
ISO, like quality standards.
Yeah, ISO 12040 and 12744. It's about looking at the entire life of a product, cradle to grave.
It's from raw material.
All the way to disposal.
Yeah.
It accounts for all the inputs, resources, energy and outputs, emissions, waste at every single stage. Growing, processing, manufacturing, transport, use, end of life.
So it gives a really complete picture.
That's the goal, a comprehensive view. It lets you make fact-based comparisons between different materials performing the same function, like hemp versus cotton for a t-shirt.
What kind of impacts does it measure?
Things like carbon footprint, water footprint, effects on water quality, eutrophication, human health impacts, resource depletion, ozone depletion, acidification, a whole range.
Sounds complex.
It is, but the idea is to get reliable quantitative data about where and when the environmental burdens happen. The process involves gathering data, assessing impacts, interpreting results, and then using that info.
To do what?
To improve processes, design better products, make things more sustainable. In textiles, LCA is becoming really important.
Why now?
It helps companies spot where they can reduce their footprint, save costs through efficiency, use resources better, and meet that growing consumer demand for eco-friendly products.
So it's not just about the farmers.
Oh, no. Retailers, manufacturers, everyone has a role. Improving production, less water, fewer chemicals, lower emissions. But consumer behavior matters too.
How we buy, wash, and dispose of clothes.
Exactly. Initiatives like the Sustainable Apparel Coalition, tools like the Higg Index, they're all pushing for this industry-wide shift based on LCA thinking.
Okay, so what does an LCA tell us specifically about hemp?
Well, like anything, it has inputs and outputs. Growing needs good soil, water, sun, CO2, the right temperature, and human labor.
Right.
Then processing involves steps like retting, drying, combing, spinning, weaving, dyeing, some of which can use water or energy or chemicals.
But the benefits?
Significant environmental benefits. Absorbing CO2 while growing, it's a carbon sink. Deep roots prevent erosion, improve soil health. Generally needs less water, fewer pesticides, less fertilizer than many crops.
Any drawbacks from an LCA perspective?
While growing, it does require land, which could mean a habitat loss if not managed well. And poor fertilizer management could lead to water pollution, like with any crop.
But compared to cotton, how does the LCA stack up?
Generally, very favorably for hemp. The research comparison shows lower water use, lower energy requirements, lower CO2 emissions, a smaller overall carbon footprint for hemp.
And it grows faster too, right?
Much faster. That quick growth cycle is another big plus environmentally.
And end of life?
Hemp is naturally biodegradable. Products made from it can often be recycled. That really helps its environmental profile compared to synthetics that persist for centuries. It improves soil, whereas cotton often degrades it.
And the product itself is durable.
Very. Strongest natural fiber, lasts longer, holds its shape, even gets softer with use, naturally resists mildew, UV light, absorbs water well, takes dye well, breathable yet insulating. All those properties contribute to a longer, more useful life, reducing the need for replacement.
Okay, so bringing this all together, it's really clear hemp is way more than just, some historical curiosity.
Absolutely. It has these really compelling sustainable advantages in how it's grown, processed.
And its uses are just incredibly diverse. Clothes, buildings, composites.
Right. And that life cycle assessment data really backs up its lower environmental impact compared to conventional stuff like cotton.
For me, the real aha moments were just how strong and versatile it is and that it actually improves the soil. That's amazing. And its potential to shake up industries looking for green alternatives.
Definitely. Those stand out.
And for you, listening, if this has got you thinking, maybe look into the specific applications that interest you most. Sustainable fashion, green building, biocomposites. There's a lot happening.
Which leads to a really interesting final thought to chew on. If hemp adoption really took off globally, what would that mean?
For supply chains.
Yeah.
Environmental policy.
Yeah, and even for the choices we make every day as consumers, could this ancient crop, could it truly become a cornerstone of a future green economy?
That is definitely something to think about.